Okay, today I will show you what you need to convert mg value to chemical formula. So you need to convert that mg value to chemical formula. So what you actually need, you need a specific mg value. Okay, then you need a isotope list. It might be optional. I think this is for advanced. Okay, and another thing, you need a freestyle of thermoscientific or Excalibur software. I think this one is not free, but the freestyle is free, and I will give the link how to download that freestyle. And you just need to make an account in their website, and I think you will download that freestyle software. So before go to that freestyle, I need to show you what I have, or what is my resources to find that mg value to chemical formula. Okay, so I make a list of isotope. Here you can see hydrogen, oxygen, nitrogen. I make a lot of things here, so you can make that list like that. And here you can see that this is a hydrogen isotope. The first one is 99% natural abundance. This is the natural abundance of hydrogen. And also same thing for oxygen, nitrogen, carbon, fluorine, etc. So, and I make the difference between the two isotopes, like these two hydrogen to one hydrogen. So I make the difference here 1.0062, and you need to remember that that difference to find out what is that in that peak. So first, just remember that one. This is the carbon 13 peak, and the difference of carbon 13 and carbon 12 is 1.003. So let's start to go to that freestyle. Okay, so first I will show you how to open that freestyle. When you open that freestyle, you can upload your file from that file and go through there and open it. But if you just recently opened that, you will find that file here, and just click on that and the file will open like that. Okay, so now the first step, what I told you, I need a specific mg value. You can see here. So from where I can get that specific mg value? So you can input from any value you have from the raw file. Like I have the Pepsi raw file. You can see here I got that file from the mg mine, and I got that value like 342, or several value like here 732 values of that mg. So my target is that one, 342.139. and remember that this is the retention time of that mg value. So 0.69 is the retention time. So remember that the value, I need to copy that. Okay, then I need to reopen that freestyle. Here you can see, and first thing I need to do, just go to chromatogram. Here you can see, and click on that, and ranges. So why ranges? Because you need to input that mass here, mg value here. So this trace type, make it mass range, and when you just first open it, it will take like a maximum 30 seconds to be mass range. So after that, after the tic to a mass range, you will find that ranges here. So simply you just input that mg value here, like it was 342.130, like I make it 4 digit. Okay, then click enter, and you will find that graph here and peak of here. So I need to stress that to find that exact value. So just make a straight line, do not make a rectangular shape of box, just stress like that. Okay, then you will find that retention time here, and click on that maximum peak, maximum height peak, and here you can see that we got 342.1389. It is not exactly 1390, but yeah, it is so close, you know that. Then I need to make a stress here. Okay, then I find that one. So then what should I do? Okay, then make right click here, and you can see here label relative to selected mass. So this is the second one, and just if you click on that, it will make the difference of that mass. So what I did, I just to make it okay, so I need to show you that what is the difference, this mass, and if you just again stress, you will find several masses. So I need the difference between them: 342, 343, 344, 345. So you can do by your calculator, but it will do in software for easy things for you. So I will do that. You can also use that calculator here, like 343 minus 342, you will find the difference, but here the software can do that for you. So level that selected value. So this is remember, this is this 342, this 342 1.1389, this is your targeted or a specific mg value, and you need to find that molecular formula or chemical formula of that mass, not that 343 or 344. So that's why I target that one, and I need the difference between other masses. So left hand side you will find that negative values, and right side of that 0 you will find that positive value or positive difference between them. So here you can see that you find, I need to cut that off because so make it large for you. So here you can see that this is 0, and I find that 1.0037. So this is the distance, or this is the difference between that two mass. So remember that this one is 342 and this one is 343. This is the difference of that. So 1.0037 is the difference between this mass and this mass. So remember that I told you from that isotope value, you need to remember that things, that difference, like hydrogen, oxygen, nitrogen, the isotope difference. Okay, so what I got here, 1.0037, you can see that 1.0037. So I need to find out the similar isotope difference here. So here you can see that 1.0033. So you can consider that 4 digit because it is not so significant, so it might be up and down. So yeah, I got 1.0037, but here you can see the 13 carbon is 1.0033. So I can take that consideration. And also you need to remember that natural abundance of that molecule, like carbon 13, this is the carbon 13 peak. Okay, so this peak is carbon 13 peak because the difference is 1.0037. So I find out that this is a carbon 13 peak, and I need to find out how many carbon 13 peak is there. So to do that, I need to find out the natural abundance of that peak or the height of that peak. So to do that, I need to stress it again. So you find out that here this peak is more visible now, and also I need to do like more visible to you. So for do that, I need to go display option here. Here you can see the display option. Okay, then make it big. I need to uh reduce that things, like it is out of the range. So okay, then I will make it more, like 15. So here you can see that this peak is 1.0037, and to do that, remember, you need to include that uh, that a specific mg value. So if this specific mg value is out of that range, I mean out of the graph, this peak will show you 100%. So this is not correct. So when you make it larger, include that main or a specific mg value, and that difference you need to find out the height of the peak. Okay, so I make it maximum 15%, and I find out that more visible that peak, and then I can show you the abundance or relative abundance of that peak. So it's almost, I think, 13.5, right? 13.5. So it should not be specific. Okay, so it can be up and down, yeah, of course. So this 1.0037, this peak is 13.5, and now you need to know that natural abundance of carbon 13, so it is 1.16. So if you calculate like 13.6 divided by 1.16, it could be like 13. So I can assume that here here is 13 carbon, or 13 carbon, yeah, 13 carbon, there is 13 carbon. Okay, so our 342, this is our original mg value, and 342.1389, this mass contains 13 carbon. Okay, so this is the way you can find out how many carbon in that peak. So this is not a specific, but it could be up and down, like 13 could be like 20, like 21, but it could not be like 1, 2, or 3, or it could be 10 also, but it is not so lower than that. So you have a assumption that there is a carbon, and you got like 13 carbon there. Okay, now make it again 0. Okay, then you got that difference 2.004. Okay, 2.004, you can see that here this is a little peak, I think. And I'm sorry for that, I cannot write on that graph. So just just this is the peak of 2.0044. So remember that I need to find out in that isotope difference here. So 2.004, here you can see that this is 18 oxygen, I mean the isotope oxygen isotope 18, and 2.0042, and you can consider that fourth digit number, it could be up and down. So this value is similar to our value 2.004. So this peak is for oxygen peak, oxygen 18 peak, and again I need to find out that height of that peak. To do that, I need to reduce that maximum, like 100 to 10, or okay, so it is more, I will make it 5 or 3. So then you can see that this height of, I mean it is more visible now, right? So I include that original peak was here, it was 0, now this peak is 2.004, and I can easily see that height of that peak, and it just, so it is like 1.85, right? This height of that peak is 1.85, I think. So okay, I got that oxygen 18 oxygen, I mean, and the height of that peak, height of that 2.004 is 1.85. So what next you need to do, you just okay, so 18 oxygen, right? Here you can see that 18 oxygen is 0.22% natural abundance, so you got 1.85, right? Like I need to show you more correctly, right? You got a peak 2.0044. This is 18 oxygen, and this height of that peak is 1.85, right? And you got that natural abundance of that oxygen 18 is 0.222%. So what you actually need to do, divided that 1.85 0.222, you will find that x value, and you will find that number of the 18 oxygen, I mean the number of oxygen in the specific 342, in the specific 342 mg value. So now here we find out two things, one is carbon and one is oxygen, and sometimes you will not find out some common element for organic compound. So actually what is the common element of organic matters? So to find out that, so you will generally find out that in organic compound there is like carbon, oxygen, nitrogen, sulfur, phosphorus, and hydrogen, of course hydrogen. So we find out that carbon and oxygen, but to find out the nitrogen, the next one, I need to show that difference of that isotope. What is the difference of the nitrogen? So for nitrogen I need to find out that 0.9970, this difference in the freestyle. So okay, then I will make it again 0. Okay, then it was, remember that it was 0.9970, so it is close to 1. I'm sorry. Okay, so this is close to 1, this is 1.0037, so this 0.9970 should be close to that, but I got here 0.9842, so this is not a nitrogen peak, but if I got that nitrogen in that compound, we can consider, because this is so tricky, and it could be because this 0.9970, okay, so like that we got a carbon peak, carbon 13 peak here, like that 1.0037. So the nitrogen peak is 0.9970, so this is very close to that, and sometimes this peak is like it attached to that peak, so sometimes because of the resolution. So if you use the low resolution, or like 21730, like this resolution, so this resolution can merge that nitrogen peak here. So if you do that isotope simulation, it is different thing, I will not talk about that in that video, but it could be in that peak. So you can assume that there is nitrogen, or yeah, you can let it just remember that it is a organic compound and there could be nitrogen in that a specific mg value. So you can consider that nitrogen here, because this is low resolution, you need to input the high resolution, then this peak could be like that. So sometimes it happens but not most of the time. So you can consider the nitrogen here. And also remember the hydrogen peak. This is so tricky to find out. This is 2 hydrogen, the abundance is 0.028%, and the difference is 1.006 to 2.0082, like that. So you will find out that difference here, but if you do not worry about that. Okay, so in that mass 3.42, okay, 3.42.1389, we get 13 carbon and 4 5 oxygen in there. Okay, so let's start to find out the chemical formula. So to do that, you need to go there. So just assume that there is nitrogen, oxygen, sulfur, phosphorus, like that element, and you need to find out the exact or nearest possible chemical formula of that 342.1389. So to do that, go to the element here. You can see, okay. So make mass here, input the mass here, and it was 342.1389. Okay, then you need to input that maximum range of the nitrogen, oxygen, carbon, hydrogen, sulfur. So it can be vary, right? It can be vary. So it is not strict way to define that there should be 10 nitrogen or something like that. So if I input the default things, nitrogen is 10 and I got 4 oxygen, so it could be also 10. I can input that 10. I got 13 carbon, so it could be 20. I got no hydrogen, but I can input here 40 hydrogen, and I do not find out. So remember that this sulfur and phosphorus, this is so tricky. So for your first attempt, you should not add any sulfur here, and chlorine and phosphorus. So their peak is really so visible here. If you do not find any difference of like sulfur, right? This phosphorus is so tricky. So for sulfur, if you do not find out this difference in the freestyle, and chlorine here, you can the difference, you can see the difference here. If you do not find out any peak of chlorine, sulfur and phosphorus, you should not put anything here, because it will make it more complicated to find out the exact chemical formula of that 342.1389. So please skip that things first time. So, and of course, if you find out that difference here, isotope difference here, you must input that value of that. So I input that things, and let's calculate that. Okay, just hit the calculate button here, and you will find out that chemical formula. Here's 3 chemical formula. I allow maximum 10, you can see here. Okay, I allow that, and I got that 3 chemical formula. So now you need to remember the nitrogen rule, the seven golden rule. I will give you the link of the 7 golden rule. You can find out there. So you need to judge that chemical formula by their nitrogen rule. So before do that, you need to remember that delta value of that, which range is more acceptable. You need to remember that. So it is like 2 is pretty good, maximum 2 is pretty good, but lower than 2 is more good, but above like 2.25 it is not so bad, but you can skip that formula like C10 H22O9 in 4. So this formula can be avoided because the delta value 2.25, so we can skip that one. Okay, and remember this is charged particle, like this formula is C11H18O5N8 plus. Why it is plus? Because remember, when you use that ESI, I mean electrospray ionization, we find that there is uh, positive charge, and we took here like positive charge, okay, and detect the positive charge. So that is why this formula is positive, not the exact molecular ion. So this is charged particle, okay. And remember, in that ESI, I mean I need to show you more. I think this is liquid chromatogram, this is mass spectroscopy, and this interface is known as ESI, or electrospray ionization. So in that portion we make actually ions. So in that case we target the positive ions, okay, and it detected in the detector like a charged particle, okay. So in that positive ion it could be M plus Ace peak or M plus NH4 peak or M plus Na or sodium peak, because this is monoisotope, I mean monocharged particle, and it could be M plus K peak, okay. So to find out that exact chemical formula of that 342.1389, you need to find out whose peak it is. This is M plus H peak or M plus NH4 or M plus Na or M plus Ka. So you need to find out that. So to do that, so I think you can see that table here. So this makes you more easy to find out the difference between that M plus Ace, M plus NH4 and M plus Na or M plus K peak. So I've already calculated that 342.1380, this is that peak. So how can I do that? So let's see in the freestyle. So to remember that the difference between M plus N is 4 and M plus Ace peak. So if I consider that one 0 0, because I already got that, I already calculated that, so you need to find out which one it is. So to do that you need to find out that difference when you get that. So if you got that positive M plus positive 17.0265, this is the 0.00 peak, because this difference is 17.02 and this is positive. But if you get that minus, or I mean negative 17.0265 peak, so this could be that 0.02. So you actually need to consider that difference between these peaks or these ions, like this is 4.95. So if this is 0.00, you will get 4.955 if there is sodium. If there is sodium, like in ESI, if you make this ion N plus Na positive, you will find the peak 4.955 distance from that one. If you don't, so you will not find out that peak. So let's see what we got from that freestyle. And listen, I already got that because I already calculated that peak. So I got that this is the M plus NH4 peak, and I will show you the difference, that 70.0265 negative. I got pick here M plus H plus, and also that one or that one, okay. So like 70.02, our target is minus 17.0265. Let's see what we find out here. So for now I need to cut this off, okay. Then I need to make it 0, okay, and I target minus, so left side I will stress out. And here you can see that 17.02, this value 17.0261, and our exact difference is 17.0265. So I can consider the fourth decimal point. So actually we got that, and this is minus. Okay, so because this is minus, so this peak, this 17.02 peak is the evidence of m plus h peak. So in ESI, uh, in ESI, I got the m plus h peak and m plus n is 4 peak, and also I'll consider the 4.955 here. What we got here, so to do that, this is 4.95 is right side of the 00. I'm sorry for that. Okay, so here you can see that 4.9557, this value, so this difference you also find out. So this peak is m plus na, or I mean this ESI makes also m plus na peak, and the last one is 21.9293. I will find out that m plus k peak here. Okay, so 21.92, right? So I need to find that value 21. Is there anyone? Okay, so this is the peak 21.93. Let's see, it is okay. So this is not exact value. I need the 21.92, not 93. So this peak 21.933, this is not the peak of m plus k. So I do not get here any m plus k peak. So our sample does not have any potassium, but our sample has m plus NH4, m plus H peak, and m plus Na peak. So listen, what we got here. So this peak, what we got here, this 3.34, 2.1389, this mass is m plus NH4 4 peak, right? So we got that, and to get that formula of that mass, I already calculated that. I just make sure to calculate that things, and okay, then I find out that formula. Okay, I think I missed that. It should be 340.1389. Okay, then calculate. Then I got that three formulas here. So I can remove that formula because the delta value is more than 2.225 or something like that. So I can consider that one. So to do that, I need you remember that this is charged particle, I mean positive charge, this one, they are all positive charged particle, and for positive charged particle there is no nitrogen rule. So if I just point out what you need to consider, so can I just remove that one? You can take a screenshot here. Okay, then okay, so what I got here, the peak is m plus NH4, right? So what is our specific mass? This is our specific mass. So I got two possible formulas here. So if I just write out the first one, this one is C11H18O5N8. Okay, C11H18O5N8. So remember, this is the charged particle. I need to make it sure that it is good or not. C11 A18O5 N8. Okay, so this is good. So this is charged particle here, and this is the peak of that. So original mass, to get the original mass, I need to subtract that NH4, so that I can got that one, right? So to get that M, the original mass of that compound, I need to subtract that NH4, which is like 18.03 or something like that. So manually, if I do that, if I remove that NH4, that's been one nitrogen and four hydrogen. If I remove that C11, hydrogen number is 4, so it should be 14 hydrogen. Oxygen same. N8, that means I need to subtract one nitrogen here, so it is N5, right? So I got that formula here, and this is the original mass of that C42.1389. So this is the molecule formula. So why I'm doing that, this is the charged particle, and I cannot apply the nitrogen rule in that charged particle. So I need to find out what is the exact formula, I mean what is the molecular formula of that, so that I can apply that nitrogen rule, and which one is good and which one is not good. So if you do that, you will find out here, like this is the even number and this is the even number, so you will find the even number molecular mass. So for nitrogen rule, even number consists 0 or even number of nitrogen, and for odd number, the nitrogen is odd number. Okay. Okay, so what we got here, so you can see here C11 H18O5 and 8, this formula consists of the even number of nitrogen here. Okay, so we can consider this one because it follows the nitrogen rule. Again, I need to see that another one, which is C12 H24O10 N, and this one is odd number of nitrogen. So you can easily eliminate that one because it does not follow that nitrogen rule. So most of the time you will find the exact or possible formulas if you apply that only nitrogen rule here. So yeah, if you got the nitrogen rule, it is only applied in the molecules. So we got here charged particle, that's why I need to find out which peak it is. It is M plus H or M plus NH4 or something else, and then I need to subtract that value. If so more thing additionally, if this is, so suppose this is M plus H peak, so what I need to do, just subtract that H plus value, it is 1.007825. So you need to subtract that things from the C4 342.1389. So it should be like what number, then you can you can accept that one. So but this is not M plus H peak, right? This is M plus N is 4 peak, right? So you need to subtract that 18.03, and there is a trick way. So to do that, I need to cut out that things. Okay. Then to do that, like what I got here, 342.1389, this is our specific mg value, right? So I need to apply that nitrogen rule here, nitrogen rule. And what is that nitrogen rule? Nitrogen rule applied for only molecule, not charged particle, but this is a charged particle. So this is the trick, you can apply it not subtract that ns4 or something like that. So what you should or remember that nitrogen diol is for odd number, you will find odd number of nitrogen, and for even number you will find zero or even number nitrogen. Okay, so the trick is that if this number is even, it should follow that odd rule of the nitrogen. If this is like 3894.1890, then this number is odd and it will apply that even rule of nitrogen. So this is the tricky way to apply that nitrogen rule, and you can easily detect the specific one, which one is the most possible or best fit for your that mass. You will find that chemical formula of that mass. Now in the last, okay, I need to cut it down, sorry. Okay, now remember that 342.1389, this is the charged value. Okay, and this is the mg value, right? Mg, and we considered the charged, you can see here, I think it is there, right? This is the charged particle, right? Okay, there is no, oh, okay, you can see here there is a charge 1. If you make it 2, it will double or it will just freak you out. So remember, this is for charge 1. So for like protein, most of the time you will find that the charge is, I'm sorry, most of the time you will find that the charge is 1, but sometimes like protein or peptides or something, that big elements, you will find out that charge is not 1, and this charge is like 2, 3, 6, 7, 9, 8, 9, like that. So what you actually need to do that time? So this is the big question, right? I think so. So what we got here, right? Just need to remember that value. Okay, I need to rescale that and make that 342. So okay, make it a stress. So you can see that two values. I will do that for two values, like 342.1389 and 343.1427. So for two values, I will show that how to do that for more cells, multiple cells. So you get that value like 31389. Here you got that 343. I need to remember, but I'm sorry. 3431427. 14, okay, 1427. And if you just subtract that 3431427 from that 342, you will find the difference 1.0037 here. And what exactly I did to find out this is the carbon peak or something like that. This is the difference between that two peaks, right? So this is mg value, this is mg value, and we input that charge mg is 1, g is 1, right? That's why this value is, we apply m, and this one is also m. But when the charge is not 1, then what we should do? We need to do divided by 2, right? Divided by 2, right? And also we need to do here 2. Okay, so this difference should be like, I already calculated that, 5.01. So you will find that peak, right, that you got now this peak here 342.1389, sorry, 89, and this difference is 1.0037 between these two peaks, 343.1427, right? This difference from this one, it is 1.0037, but the charge is 2. If we apply that charge is 2, the difference should be 0.501. Then this value also modified, right? So this value could be 342 plus 0.501. So this is like 342.6390, like that. So you can calculate that, I think. So this value is 3.342.6390, and you will find out that difference is 0.501. So most of the time for the simple compound, you will find the charge is to 1, but sometimes if you are not lucky, I think, then you will find out that charged multiple charge like 2, 3, 6, 7. It happens for the protein or peptides. So I think if I this is a long video, I think, and if I just summarize that, you just need a specific mg value, right? Then you need a software named Freestyle. It is available in the internet, and I will give you the link in that description. And you need the isotope, yes, isotope difference. Here you just make a word file of that, and then you need to open that Freestyle and input that specific mass here, and then you will find out which elements is there, like carbon, oxygen, nitrogen, like that, and also input that values in the elemental, right? Here you can see that option, elemental option, and input that mass here, specific mass here, and input that your assumption, like best assumption here. Okay, it can be up down, right? These numbers can be up down, and then you apply that calculate here. You will find out the formula here. Then you apply the nitrogen rule, and also you can apply that 7 golden rule, which is like uh, hydrogen by carbon, what is the ratio of that, and there is a specific range of that ratio. So you can also apply that 7 golden rule to find out the exact formula. And remember that to go there or to apply that nitrogen rule, you need to find out that this value is m plus h peak or m plus nh4, and then you can use also that tricky way to find out that nitrogen rule, and then you can do that. And this is all for one search, but for multiple search you need to do that things, you need to divide the distance of that. So yeah, these things you need to remember to find out the exact, or I think best fit of that mass. So it sometimes very difficult to find out that mm, more than 500 mg value. So remember, so brace. I think you can do that. Yeah, of course you can do that. Thank you so much for watching.